Lesson 644, Factoring Polynomials by Grouping. When factoring a polynomial using the grouping strategy, the first thing we must do is determine which terms we want to group together. In this problem, x squared plus 2x minus 5x minus 10, we are going to group the first two terms together and the last two terms together. Now, for each group, we need to determine if there are any factors that the terms have in common and use the biggest one. In other words, we want to find the greatest common factor, or GCF, for each group. For the first group, we notice that each of the terms has an x in common. X squared is equivalent to x times x, and 2x is equivalent to 2 times x. This means we can factor an x out for both terms. So for this first group, factoring out the GCF yields x times the quantity of x plus 2. In our second group, the common factor that both negative 5x and negative 10 have in common is negative 5. Factoring out a negative 5 yields the quantity of x plus 2. Now that we have pulled a GCF from the first group and another GCF from the second group, do you notice anything about the new factors that were created? There is an x plus 2 factor in both groups. In fact, the goal of factoring by groups is to find a common binomial factor that exists between the groups of terms, and it looks like we have. Notice that if we do not find a common set of binomial factors at this step, then we need to double-check that we have actually used the greatest common factor as a factor, or we might want to begin again and try grouping the terms together differently. So, returning to our problem, now that we have a common binomial factor of x plus 2, we can factor it to the front of our expression. When we pull this group forward, we write down what is left. X squared plus 2x minus 5x minus 10 is equivalent to the quantity of x plus 2 times the quantity of x minus 5. Now, let's consider what this process would look like visually. Remember, the constant term is represented by the small square unit tile that is 1 unit by 1 unit on each side so that the area of this square is 1. Our linear term is represented by the 1x tile that is 1 unit long by x units wide so that the area of this rectangular tile represents 1x. The quadratic term is a large square with dimensions that measure x along each of its sides. Notice that when we select the tiles to use, we need the negative versions of our unit tile to represent negative 10. We also need negative linear tiles to represent negative 5x. Next, we must organize the tiles into a rectangle. To help us with the process, we may want to use our groups as a hint for how to arrange the tiles. Notice that the first group of tiles representing x squared plus 2x can be placed along one edge. Along the second edge, we want to place the negative 5x tiles. Once those are in place, we fill in the rest of the rectangle with the negative 10 unit tiles. Once our rectangle has been created, we need to read the dimensions along each side of the figure. Recall that we are reading the length each tile measures. Along the top edge, we can see that it is 1x tile and negative 5 units along the edge. In other words, x minus 5. For the side factor, it is 1x tile and 2 positive units long, or the quantity of x plus 2. Thus, x squared plus 2x minus 5x minus 10 factors to be the quantity of x plus 2 times the quantity of x minus 5. This is the same answer we arrived at using algebraic grouping.